sided with a right-wing Texas judge who argued the FDA improperly applied the FDA's scientific independent judgment and imposed outdated restrictions on access to safe and effective abortion medication. For now, that the program remains available with telemedicine, mail delivery, and via pharmacies. Supreme Court felony obstruction statute that's been used by the Justice Department for delivery to people in the January 6th Capitol insurrection, including Donald Trump. The court's decision could invalidate convictions against those involved in the insurrection and hamper special counsel Jack's investigation against Trump. Separately, Justice is considering the special counsel's report of Trump's claim to presidential immunity. In related news, CNN's published reportings of former Trump official Kevin Chesbrough revealing Trump was told about the fake elector scheme to keep him in office, found by the lawyer David Purvis that he lost the state of Wisconsin revelation. Interviews with the architect of the false electors plot is cooperating with investigations into Trump's in Arizona and Nevada. In October, he pleaded guilty in Georgia's sweeping election subversion case. House Republicans approved the resolution authorizing an impeachment inquiry into President Biden. Republicans accused Biden of abusing his position to advance his family's business interests and probe into the allegations has not returned any evidence. Democratic Congressmember Amy Raskin, ranking member of the House Committee on Oversight and Accountability, said, quote, everyone knows that the floundering Biden impeachment probe is designed to give Donald Trump something to say when it's pointed out he's been twice impeached as a proven fraudster, sexual assailant, and detainer of women, and now faces 91 felony charges in federal and state court, unquote. This comes as Hunter Biden made rare public comments Wednesday. The president signed to fight a subpoena from House Republicans and instead spoke to press in front of the Capitol.
For 6 years, I've been the target of the unrelenting Trump attack machine, shouting, "Where's Hunter?" Well, here's my answer.
So much resource, but I think it was pulled forward in time. You know, we kind of did it ahead of when we quote unquote should have done it.
Yeah.
And so in that way, it's also a technical marvel. I mean, it's truly incredible. It's the 20th century version of building the pyramids or something. It's, you know, it's an achievement that because it was pulled forward in time, because it did something that others had thought possible, it rightly deserves its place as, you know, in the pantheon of great human achievements.
And of course, you named the projects, the rockets that Blue Origin is working on after some of the folks involved. I don't understand why I didn't say New Gagarin.
There's an American bias in the Navy. I apologize.
Very strange.
Alexa. I'm a big fan of Gagarin's, though. And in fact, I think his first words in space, I think, are incredible. He proportionally said, "My God, it's blue." And that really drives home. No one had seen the Earth from space. No one knew that we were on this blue planet. No one knew what it looked like from out there. And Gagarin was the first person to see it.
One of the things I think about is how dangerous those early days were for Gagarin, for Glenn, for everybody involved. Like how big of a risk they were all
They were taking huge risks. I'm not sure what the Soviets thought about Gagarin's flight, but I think that the Americans thought that the Alan Shepard flight, the flight that, you know, New Shepard is named after, the first American space, on his suborbital flight, they thought he had about a 75% chance of success. So, you know, that's a pretty big risk, a 25% risk.
It's kind of interesting that Alan Shepard is not quite as famous as John Glenn. So for people who don't know, Alan Shepard is the first astronaut.
The first American in space.
American in suborbital flight.
Correct.
And then the first orbital flight is...
And John Glenn is the first American to This is a letter about New Glenn from the original Glenn, and he's got a great sense of humor, and he's very happy about it and grateful. It's very sweet.
Does he say P.S. don't mess this up, or is that
No, he doesn't.
make me look good?
He doesn't do that. But John, wherever you are, we got you covered.
Good. So back to maybe the big picture of space. When you look up at the stars and think big, what do you hope is the future of humanity? Hundreds, thousands of years from now, out in space.
I would love to see, a trillion humans living in the solar system. If we had a trillion humans, we would have, at any given time, 1,000 Mozarts and 1,000 Einsteins. That would, our solar system would be full of life and intelligence and energy. And we can easily support a civilization that large with all of the resources in the solar system.
So what do you think that looks like? Giant space stations?
Yeah, the only way to get to that vision is with giant space stations. The planetary surfaces are just way too small. So you could, unless you turn them into giant space stations or something. But yeah, we will take materials from the moon and from near Earth objects and from the asteroid belt and so on, and we'll build giant O'Neill-style colonies, and people will live in those. And they have a lot of advantages over planetary surfaces. You can spin them to get normal Earth gravity. You can put them where you want them. I think most people are going to want to live near Earth, not necessarily in Earth orbit, but in Earth, but near Earth vicinity orbits, and so they can move relatively quickly back and forth between their station and Earth. So, but I think a lot of people, especially in the early stages, are not going to want to give up Earth altogether.
They go to Earth for vacation.
Yeah, same way that you might go to Yellowstone National Park for vacation. People will, and people get to choose whether they live on Earth or they live in space, but they'll be able to use much more energy and much more material resource in space than they would be able to use on Earth.
One of the interesting ideas you had is to move the heavy industry away from Earth. So people sometimes have this idea that somehow space exploration is in conflict with the celebration of the planet Earth, that we should focus on preserving Earth. And basically your idea is that space travel, space exploration is a way to preserve Earth.
Exactly. This planet, we've sent robotic probes to all the planets. We know that this is the good one.
Play favorites.
But Earth really is the good planet. It's amazing. The ecosystem we have here, all of the life and the lush, the plant life and the water resources, everything. This planet is really extraordinary. And of course, we evolved on this planet, so of course it's perfect for us. But it's also perfect for all the advanced life forms on this planet, all the animals and so on. And so this is a gem. We do need to take care of it. And as we enter the Anthropocene, as we humans have gotten so sophisticated and large and impactful, as we stride across this planet, it's that is going to, as we continue, we want to use a lot of energy. We want to use a lot of energy per capita. We've gotten amazing things. We don't want to go backwards. If you think about the good old days, they're mostly an illusion. Like in almost every way, life is better for almost everyone today than it place. It was definitely. And then I realized I was going to be a mediocre theoretical physicist. And there were a few people in my classes, like in quantum mechanics and so on, who they could effortlessly do things that were so difficult for me. And I realized, like, there are 1,000 ways to be smart. And to be really, theoretical physics is not one of those fields where only the top few percent actually move the state of the art forward. It's one of those things where you have to be really, your brain has to be wired in a certain way. And there was a guy named, one of these people who was convinced me, he didn't mean to convince me, but just by observing him, he convinced me that I should not try to be a theoretical physicist. His name was Yosanta. And Yosanta was from Sri Lanka. And he was one of the most brilliant people I'd ever met. My friend Joe and I were working on a very difficult partial differential equations problem set one night. And there was one problem that we worked on for 3 hours. And we made no headway whatsoever. And we looked up at each other at the same time and we said, Yosanta. So we went to Yosanta's dorm room and he was there. He was almost always there. And we said, Yosanta, we're having trouble solving this partial differential equation. Would you mind taking a look? And he said, of course. By the way, he was the most humble, most kind person. And so he looked at our problem and he stared at it for just a few seconds, maybe 10 seconds. And he said, cosine. And I said, what do you mean, Yosanta? What do you mean cosine? He said, that's the answer. And I said, no, come on. And he said, let me show you. And he took out some paper. And he wrote down 3 pages of equations. Everything canceled out. And the answer was cosine. And I said, Yosanta, did you do that in your head? And he said, oh no, that would be impossible. A few years ago, I solved a similar problem. And I could map this problem onto that problem. And then it was immediately obvious that the answer was cosine. I had a few, if you have an experience like that, you realize maybe being a theoretical physicist isn't what the universe wants you to be. And so I switched to computer science, and that worked out really well for me. I enjoy it. I still enjoy it today.
Yeah, there's a particular kind of intuition you need to be a great physicist applied to physics.
I think the mathematical skill required today is so high. You have to be a world-class mathematician to be a successful theoretical physicist today. And it's not, you probably need other skills too, intuition, lateral thinking, and so on. But without just top-notch math skills, you're unlikely to be successful.
And visualization skill, you have to be able to really kind of do these kind of thought experiments. And if you want truly great creativity, actually Walter Isaacson writes about you, puts you on the same level as Einstein.
Well, that's very kind. I'm an inventor. If you want to boil down what I am, I'm really an inventor. And I look at things and I can come up with atypical solutions, and then I can create 100 such atypical solutions for something. 99 of them may not survive, scrutiny, but one of those 100 is like, maybe that might work, and then you can keep going from there. So that kind of lateral thinking, that kind of in a high dimensionality space where the search space is very large, that's where my inventive skills come. That's the thing I self-identify as an inventor more than anything else.
Yeah, and he describes it in all kinds of different ways. Walter Isaacson does that creativity combined with childlike wonder that you've maintained still to this day, all of that combined together. Is there, like, if you were to study your own brain, introspect, how do you think? What's your thinking process like? We'll talk about the writing process of putting it down on paper, which is quite rigorous and famous at Amazon. But how do you, when you sit down, maybe alone, maybe with others, and thinking through this high-dimensional space?
If you look at, for example, rocket engines have turbopumps. They have to pressurize the fuel and the oxidizer up to a very high pressure level in order to inject it into the thrust chamber where it burns. And those pumps, all rotating machines in fact, get more efficient as they get larger. So really tiny turbo pumps are very challenging to manufacture, and any kind of gaps, are like between the housing, for example, and the rotating impeller that pressurizes the fuel. There has to be some gap there. You can have those parts screaming against one another, and those gaps drive efficiencies. And so, if you have a very large turbo pump, those gaps in percentage terms end up being very small. And so there's a bunch of things that you end up loving about having a large rocket, and that you end up hating for a small rocket. But there's a giant exception to this rule, and it is manufacturing. So manufacturing large structures is very, very challenging. It's a pain in the butt. And so, it's just, if you're making a small rocket engine, you can move all the pieces by hand, you can assemble it on a table, one person can do it. You don't need cranes and heavy lift operations and tooling and so on and so on. When you start building big objects, infrastructure, civil infrastructure, just like the launch pad and all this, we went and visited, I took you to the launch pad, and you can see it's so monumental. And so just these things become major undertakings, both from an engineering point of view, but also from a construction and cost point of view.
And even the foundation of the launch pad. I mean, this is Florida. Is it like swampland? Like, how deep
You
do you
have
have to go?
at Cape Canaveral.
Yeah.
In fact, in most ocean, most launch pads are on beaches somewhere in the ocean, because you want to launch over water for safety reasons. Yes, you have to drive pilings, dozens and dozens of pilings, 50, 100, 150 feet deep to get enough structural integrity for these very large, yes, these turn into major civil engineering projects.
I just have to say, everything about that factory is pretty badass. It's tooling. The bigger it gets, the more epic it is.
It does make it epic.
Yeah.
It's fun to look at. It's extraordinary.
Humbling. Also, that humans are so small compared to it.
We are building these enormous machines that are harnessing enormous amounts of chemical power, in very, very compact packages. It's truly extraordinary.
But then there's all the different components, and the materials involved. Is there something interesting that you can describe about the materials that comprise the rocket? So it has to be as light as possible, I guess, whilst withstanding the heat and the harsh conditions.
Yeah, I play a little kind of game sometimes with other rocket people that I run into, where what are the things that would amaze the 1960s engineers? Like what's changed? Because surprisingly, some of rocketry's greatest hits have not changed. They would recognize immediately a lot of what we do today, and it's exactly what they pioneered back in the 60s. But a few things have changed. The use of carbon composites is very different today. We can build very sophisticated. You saw our carbon tape laying machine that builds the giant fairings, and we can build these incredibly light, very stiff fairing structures out of carbon composite material that they could not have dreamed of. I mean, the efficiency, the structural efficiency of that material is so high compared to any, metallic material you might use or anything else. So that's one. Aluminum lithium, and the ability to friction stir weld aluminum lithium. Do you remember the friction stir welding that I showed you? This is a remarkable technology. It was invented decades ago, but has become very practical over just the last couple of decades. And instead of using heat to weld two pieces of metal together, it literally stirs the two pieces. There's a pin that rotates at a certain rate, and you put that pin between the two plates of metal that you want to weld together, and then you move it at a very precise speed And instead of heating the material, it heats it a little bit because of friction, but not very much. You can literally, immediately after welding with stir friction welding, you can touch the material and it's just barely warm. It literally stirs the molecules together. It's quite extraordinary.
Relatively low temperature, and I guess high temperature is what makes that makes it a weak point.
Exactly. So with traditional welding techniques, you may have whatever the underlying strength characteristics of the material are, you end up with weak regions where you weld. And with friction stir welding, the welds are just as strong as the bulk material. So it really allows you, so because when you're, let's say you're building a tank that you're going to pressurize, a large, liquid natural gas tank for a booster stage, for example, if you are welding that with traditional methods, you have to size those weld lands, the thickness of those pieces, with that knockdown for whatever damage you're doing with the weld, and that's going to add a lot of weight to that tank.
I mean, even just looking at the fairings, the result of that, the complex shape that it takes, and what it's supposed to do is kind of incredible, because some people don't know it's on top of the rocket, it's going to fall apart. That's its task, but it has to stay strong sometimes, and then disappear when it needs to.
That's right.
So very difficult task.
Yes. When you need something that needs to have 100% integrity until it needs to have 0% integrity, it needs to stay attached until it's ready to go away, and then when it goes away, it has to go away completely. You use explosive charges for that. And so it's a very robust way of separating structure when you need to.
Exploding.
Yeah, little tiny bits of explosive material, and it'll sever the whole connection.
So if you want to go from 100% structural integrity to 0 as fast as possible,
Use explosives.
the entirety of this thing is so badass. Okay, so back to the 2 stages. So
Not. I think that the first launch for sure, and I hope Escapade too.
hope.
Well, I just don't know which mission is actually going to be slated on. So we also have other things that might go on that first mission.
Oh, I got it. But you're optimistic that the launch will still.
Oh, the first launch, I'm very optimistic that the first launch of New Glenn will be in 2024, and I'm just not 100% certain what payload will be on that first launch.
Are you nervous about it?
Are you kidding? I'm extremely nervous about it.
Oh, man.
100%. Every launch I go to, for New Shepard, for other vehicles too, I'm always nervous for these launches. But yes, for sure, a first launch, to have no nervousness about that would be, some sign of derangement, I think. So,
Well, I got to visit the launch. It's pretty epic.
we have done a tremendous amount of ground testing, a tremendous amount of simulation. So, a lot of the problems that we might find in flight have been resolved, but there are some problems you can only find in flight. So, cross your fingers. I guarantee you'll have fun watching it no matter what happens.
100%. When the thing is fully assembled, it comes up.
Yeah, the transporter erector. Just
The erector,
the
yeah.
transporter erector for a rocket of this scale
Yeah.
is extraordinary.
That's an incredible
The
machine.
vehicle travels out horizontally and then kind of,
Yeah.
comes up.
Over a few hours.
Yeah, it's a beautiful thing to watch.
Speaking of which, if that makes you nervous, I don't know if you remember, but you were aboard New Shepard on its first crewed flight. How was that experience? Were you terrified then?
Strangely, I wasn't.
You ride the rocket? Less than ever.
I've watched other people ride the rocket, and I'm more nervous than when I was inside the rocket myself. It was a difficult conversation to have with my mother when I told her I was going to go on the first one.
Yeah.
And not only was I going to go, but I was going to bring my brother too. This is a tough conversation to have with a mom. And
That's a long pause.
both of you. And it was an incredible experience, and we were laughing inside the capsule, and we're not nervous. People on the ground were very nervous for us. It was actually one of the most emotionally powerful parts of the experience was not what happened even before the flight. At 4:30 in the morning, brother and I are getting ready to go to the launch site, and Lauren is going to take us there in her helicopter, and we're getting ready to leave, and we go outside the ranch house there in West Texas where the launch facility is, and all of our family, my kids and my brother's kids and our parents and close friends are assembled there, and they're saying goodbye to us, but they're kind of saying, maybe they think they're saying goodbye to us forever. And, we might not have felt that way, but it was obvious from their faces how nervous they were, that they felt that way. And it was sort of powerful because it allowed us to see, it was almost like attending your own memorial service or something, like you could feel how loved you were in that moment. And it was really amazing.
Yeah, and I mean, there's just a epic nature to it too.
The ascent, the floating in zero gravity, I'll tell you something very interesting. Zero gravity feels very natural. I don't know if it's because we've like returned to the womb.
You just
or
confirmed you're an alien, but I think that's what you just said.
It feels so natural to be in zero G. It was really interesting. And then when people talk about the overview effect and seeing Earth from space, I had that feeling very powerfully. I think everyone did. You see how fragile the Earth is. If you're not an environmentalist, it will make you one. The great Jim Lovell quote, he looked back at the Earth from space, and he said he realized you don't go to heaven when you die, you go to heaven when you're born. And it's just, that's the feeling that people get when they're in space. You see all this blackness, all this nothingness, and there's one gem of life, and it's Earth.
It's a gem. You've talked a lot about decision making throughout your time with Amazon. What was that decision like to be the first to ride New Shepherd? Before you talk to your mom?
Yeah.
What the pros and cons? Like actually, as one human being, as a leader of a company, on all fronts, like what was that decision making like?
I decided that, first of all, I knew the vehicle extremely well. I know the team who built it. I know the vehicle. I'm very comfortable with the escape system. We put as much effort into the escape system on that vehicle as we put into all the rest of the vehicle combined. It's one of the hardest pieces of engineering in the entire New Shepard architecture.
Can you actually describe what you mean by escape system? What's it called?
We have a solid rocket motor in the base of the crew capsule, so that if anything goes wrong on ascent, while the main rocket engine is firing, we can ignite this solid rocket motor in the base of the crew capsule and escape from the booster. It's a very challenging system to build, design, validate, test, all of these things. It is the reason that I am comfortable letting anyone go on New Shepard. So the booster is as safe and reliable as we can make it. But we are harnessing, whenever you're talking about rocket engines, I don't care what rocket engine you're talking about, you are harnessing such vast power in such a small, compact geometric space. The power density is so enormous that it is impossible to ever be sure that nothing will go wrong. And so the only way to improve safety is to have an escape system. And historically, human-rated rockets have had escape systems. Only the space shuttle did not. And but Apollo had one. All of the previous, Gemini, etc. They all had escape systems. And we have on New Shepard unusual escapes. Most escape systems are towers. We have a pusher escape system. So the solid rocket motor is actually embedded in the base of the crew capsule, and it pushes. And it's reusable in the sense that if we don't use it, so if we have a nominal mission, we land with it. The tower systems have to be So again, cost really matters on these things. So we figured out how to have the escape system be a reusable, in the event that it's not used, it can reuse it, and have it be a pusher system. It's a very sophisticated thing. So I know these things. You asked me about my decision to go. And so I know the vehicle very well. I know the people who designed it. I have great trust in them. Doubt the metrics. And an early example of this was we had metrics that showed that our customers were waiting, I think, less than, 60 seconds when they called a 1-800 number to get, phone customer service. The wait time was supposed to be less than 60 seconds. But we had a lot of complaints that it was longer than that. And anecdotally, it seemed longer than that. Like, I would call customer service myself. And so one day we're in a meeting or going through the WBR and the weekly business review. And we get to this metric in the deck. And the guy who leads customer service isn't fit in the metric. And I said, okay, let's call. Picked up the phone and I dialed the 1-800 number and called customer service. And we just waited in silence for the...
What did it turn out to be?
Oh, it was really long. 10 minutes, I think.
Oh, wow.
I mean, it was many minutes. And so, it dramatically made the point that something was wrong with the data collection. We weren't measuring the right thing. And that, set off a whole chain of events where we started measuring it right. And that's an example, by the way, of truth telling. Is like, that's an uncomfortable thing to do. But you have to say the truth, even when it's uncomfortable. And you have to get people's attention, and they have to buy into it, and they have to get energized around really fixing things.
So that speaks to the obsession with the customer experience. So one of the defining aspects of your approach to Amazon is just being obsessed with making customers happy. I think companies sometimes say that, but Amazon is really obsessed with that. I think there's something really profound to that, which is seeing the world through the eyes of the customer, like the customer experience, the human being that's using the product, that's enjoying the product, like the subtle little things that make up their experience. Like, how do you optimize those?
This is another really good and kind of deep question, because there are big things that are really important to manage, and then there are small things internally to Amazon. We call them paper cuts. So we're always working on the big things. Like, if you ask me, and most of the energy goes into the big things, as it should. So and you can identify the big things, and I would encourage anybody, if anybody listening to this is an entrepreneur, has a small business, whatever, think about the things that are not going to change over 10 years, and those are probably the big things. So, like, I know that in our retail business at Amazon, 10 years from now, customers are still going to want low prices. I know they're still going to want fast delivery, and I just know they're still going to want big selection. So it's impossible to imagine a scenario where 10 years from now, I say, where a customer says, I love Amazon, I just wish the prices were a little higher. Or, I love Amazon, I just wish you delivered a little more slowly. So when you identify the big things, you can tell they're worth putting energy into because they're stable in time. Okay. But you're asking about something a little different, which is in every customer experience, there are those big things. And by the way, it's astonishingly hard to focus even on just the big things. So even though they're obvious, they're really hard to focus on. But in addition to that, there are all these little tiny customer experience deficiencies. And we call those paper cuts. And we make long lists of them. And then we have dedicated teams that go fix paper cuts. Because the teams working on the big issues never get to the paper cuts. They never work their way down the list to get to, they're working on big things, as they should, and as you want them to. And so you need special teams who are charged with fixing paper cuts.
Well, where would you put on the paper cut spectrum the buy now with one click, which is, I think, pretty genius. So to me, like, okay, my interaction with things I love on the internet, there's things I do a lot. I, maybe representing regular human, I would love for those things to be frictionless. For example, booking airline tickets. Just saying. But it's buying a thing with one click, making that experience frictionless, intuitive, all aspects of it. Like that just fundamentally makes my life better. Not just in terms of efficiency, in terms of some kind of
Cognitive load.
yeah, cognitive load and inner peace and happiness. First of all, buying stuff is a pleasant experience. Giving enough money to buy a thing and then buying it is a pleasant experience. And like having pain around that is somehow just you're rooting a beautiful experience. And I guess all I'm saying as a person who loves good ideas is that a paper cut a solution to a paper cut.
Yes. So it's a problem. That particular thing is probably a solution to a number of paper cuts. So if you go back and look at our order pipeline and how people shopped on Amazon before we invented one-click shopping, there was more friction. There was a whole series of paper cuts, and that invention eliminated a bunch of paper cuts. And I think you're absolutely right, by the way, that when you come up with something like one-click shopping, again, this is like so ingrained in people now. Perhaps did you even notice it? I mean,
Every time I click the button,
most people never
surge of happiness.
There is in the perfect invention for the perfect moment in the perfect context, there is real beauty. Yeah. It is actual beauty, and it feels good. It's emotional. It's emotional for the inventor. It's emotional for the team that builds it. It's emotional for the customer. It's a big deal. And you can feel those things.
But to keep coming up with that idea, with those kinds of ideas, I guess is the day one thinking effort.
Yeah, you need a big group of people who feel that kind of satisfaction with creating that kind of beauty.
There's a lot of books written above you. There's a book, Invent and Wander, where Walter Isaacson does an intro. It's mostly collected writings of yours. I've read that. I also recommend people check out the Founders podcast. That covers you a lot, and it does different analysis of different business advice you've given over the years. I bring all that up because I saw that there a mention that you said that books are an antidote for short attention spans. And I forget how it was phrased, but that when you were thinking about the Kindle, that you're thinking about how technology changes us. Yeah.
We co-evolve
Yeah.
with our tools. So, we invent new tools, and then our tools change us.
Which is fascinating to think
It
about.
goes in a circle.
And there's some aspect, even just inside business, where you don't just make the customer happy, but you also have to think about, like, where is this going to take humanity if you zoom out a bit.
100%. And, you can feel in your brains are plastic, and you can feel your brain getting reprogrammed. I remember the first time this happened to me was when Tetris first came on the scene. I'm sure anybody who's been a game player has this experience where you close your eyes to lay down to go to sleep, and you see all the little blocks moving, and you're kind of rotating them in your mind, and you can just tell as you walk around the world that you have rewired your brain to play Tetris. But that happens with everything. And so, one of the, I think, we still have yet to see the full repercussions of this, I fear. But I think one of the things that we've done online, and largely because of social media, is we have trained our brains to be really good at processing super short form content. And, your podcast flies in the face of this. You do these long format things. And reading books is a long format thing. And we all do more of, if something is convenient, we do more of it. And so when you make tools, we carry around we carry around in our pocket a phone. And one of the things that one of the ways we're co-evolving with that tool. But I think it's important to spend some of your time and some of your life doing long attention span things.
Yeah, I think you've spoken about the value in your own life of focus, of singular focus on a thing for prolonged periods of time. And that's certainly what books do. And that's certainly what that piece of technology does. But I bring all that up to ask you about another piece of technology, AI, that has the potential to have various trajectories to have an impact on human civilization. How do you think AI will change us? It seems that large language models are very good at sounding like they're saying a true thing, but they don't require or often have a grounding in sort of a mathematical truth. It could just, basically, is a very good bullshitter. So if there's not enough data, if there's not enough sort of data in the training data about a particular topic, it's just going to concoct accurate sounding narratives, which is a very fascinating problem to try to solve. How do you get language models to infer what is true and not, to sort of introspect?
Yeah, they need to be taught to say, I don't know, more often.
Yeah.
And I know of several humans who could be taught that as well.
And then the other stuff, because you're still a bit involved in the Amazon side with the AI things, the other open question is what kind of products are created from this?
Oh, so many.
Yeah.
I mean, we have Alexa and Echo, and Alexa has, hundreds of millions of installed base, inputs. And so there's Alexa everywhere, and guess what? Alexa is about to get a lot smarter.
Yeah.
And so that's really, from a product point of view, that's super exciting.
There's so many opportunities there.
So many opportunities. Shopping assistant, all that stuff is amazing. At AWS, we're building Titan, which is our foundational model. We're also building Bedrock, which are corporate clients at AWS, our enterprise clients. They want to be able to use these powerful models with their own corporate data without accidentally contributing their corporate data to that model.
Yeah.
So those are the tools we're building for them with Bedrock. So there's tremendous opportunity here.
Yeah, the security, the privacy, all those things are fascinating. There's so much value can be gained by training on private data, but you want to keep this secure. It's a fascinating technical problem.
This is a very challenging technical problem, and it's one that we're making progress on and dedicated to solving for our customers.
Do you think there will be a day when humans and robots, maybe Alexa, have a romantic relationship?
Well, I think if you look at the spectrum of human variety of what people like, sexual variety,
yes.
There are people who like everything. So the answer to your question has to be yes. I
guess I'm asking
don't know
when.
how widespread that will be.
All right.
But it will happen.
I was just asking one for a friend, but it's all right. Moving on. Next question. What's a perfectly productive day in the life of Jeff Bezos? You're one of the most productive humans in the world.
Well, first of all, I get up in the morning and I putter. I have a coffee.
Can you define putter?
Just like I slowly move around. I'm not as productive as you might think I am. Because I do believe in wandering, and I read my phone for a while. I read newspapers for a while. I chat with Laura, and I drink my first coffee. So I move pretty slowly in the first couple of hours. I get up early, just naturally, and then I exercise most days, and most days it's not that hard for me. Some days it's really hard, and I do it anyway. I don't want to, and it's painful, and I'm like, why am I here? And I don't want to do it.
Why am I here at the gym?
Why am I here at the gym? Why don't I do something else? It's not always easy.
What's your source of motivation in those moments?
I know that I'll feel better later if I do it. And so, the real source of motivation, I can tell the days when I skip it. I'm not quite as alert. I don't feel as good. And then there's harder motivation longer term, you want to be healthy as you age. You know, you want health span. You want, ideally, you know, you want to be healthy and moving around when you're 80 years old. You know, and so there's a lot of, but that kind of motivation is so far in the future, it can be very hard to work into the second. So thinking about the fact I'll feel better in about 4 hours if I do it now. I have more energy for the rest of my day, and so on and so on.
What's your exercise routine? Just to linger on that. How much you curl? I mean, what are we talking about here? That's all I do at the gym. So
my routine, you know, on a good day, I do about half an hour of cardio, and I do about 45 minutes of weightlifting, resistance training of some kind, mostly weights. I have a trainer who, you know, I love, who pushes me, which is really helpful. You know, I'll be like, he'll say, Jeff, you see, can we go up on that weight a little bit? And I'll think about it, and I'll be like, no, I don't think so. And he'll look at me and say, yeah, I think you can. And of course he's right.
Yeah,
and so it's helpful to have somebody push you a little bit.
But almost every day you do that.
I do almost every day. I do a little bit of cardio and a little bit of weightlifting, and I rotate. I do a pulling day and a pushing day and a leg day. It's all pretty standard stuff.
So puttering, coffee, gym.
Puttering, coffee, gym, and then work.
What's work look like? What are the productive hours look like for you?
A couple years ago, I left as the CEO of Amazon, and I have never worked harder in my life. I am working so hard, and I'm mostly enjoying it, but there are also some very painful days. Most of my time is spent on Blue Origin, and I'm so deeply involved here now for the last couple of years. In the big, I love it. In the small, there's all the frustrations that come along with everything. You know, we're trying to get to rate manufacturing, as we talked about. That's super important. We'll get there. We just hired a new CEO, a guy I've known for close to 15 years now, a guy named Dave Limp, who I love. He's amazing. You know, so we're super lucky to have Dave, and you know, you're gonna see us move faster there. But so my day of work, you know, reading documents, having meetings. Sometimes in person, sometimes over Zoom, depends on where I am. It's all about, you know, the technology, it's about the organization, it's about, you know, I'm very, I have architecture and technology meetings almost every day on various subsystems inside the vehicle, inside the engines. It's super fun for me. My favorite part of it is the technology. My least favorite part of it is, you know, building organizations and so on. That's important, but it's also my least favorite part. So, you know, that's what they call work. You don't always get to do what you want to do.
How do you achieve time where you can focus and truly think through problems?
I do little thinking retreats. So, this is not the only, I can do that all day long. I'm very good at focusing. I'm very good at, you know, I don't keep to a strict schedule. Like my meetings often go longer than I plan for them to because I believe in wandering. I love that my perfect meeting starts with a crisp document. So the document should be written with such clarity that it's like angels singing from on high. I like a crisp document and a messy meeting. And so the meeting is about like asking questions that nobody knows the answer to and trying to like wander your way to a solution. And because and that is when that happens just right, it makes all the other meetings worthwhile. It feels good. It has a kind of beauty to it. It has an aesthetic beauty to it. And you get real breakthroughs in meetings like that.
You actually described the crisp document like this is one of the legendary aspects of Amazon, of the way you approach meetings. This is the 6-page memo. Maybe you can first describe the process of running a meeting with memos.
Meetings at Amazon and at Blue Origin are unusual. When we get when new people come in, like a new executive joins, they're a little taken aback sometimes because a typical meeting the memo, or maybe not read it at all, and they're trying to catch up. And also bluffing like they were in college, having pretended to do the reading. It's better just to carve out the time for people. So now we're all on the same page. We've all read the memo. And now we can have a really elevated discussion. And this is so much better from having a slideshow presentation, a PowerPoint presentation of some kind, where that has so many difficulties. But one of the problems is PowerPoint is really designed to persuade. It's kind of a sales tool. And internally, the last thing you want to do is sell. You're truth seeking. You're trying to find truth. And the other problem with PowerPoint is it's easy for the author and hard for the audience. And a memo is the opposite. It's hard to write a 6-page memo. A good 6-page memo might take 2 weeks to write. You have to write it, you have to rewrite it, you have to edit it, you have to talk to people about it, they have to poke holes in it for you, you write it again. It may take 2 weeks. So the author, it's really a very difficult job. But for the audience, it's much better. So you can read a half hour. There are little problems with PowerPoint presentations too. Senior executives interrupt with questions halfway through the presentation. That question's going to be answered on the next slide, but you never got there. But if you read the whole memo in advance, I often write lots of questions that I have in the margins of these memos, and then I go cross them all out because by the time I get to the end of the memo, they've been answered. That's why I save all that time. You also get, the person who's preparing the memo. We talked earlier about group think and the fact that I go last in meetings and that you don't want your ideas to kind of pollute the meeting prematurely. The author of the memo is kind of got to be very vulnerable. They got to put all their thoughts out there, and they get to go first. But that's great because it makes them really good, and you get to see their real ideas. And you're not trampling on them accidentally in a big PowerPoint presentation.
What's that feel like when you've authored a thing and then you're sitting there and everybody's reading your thing? You're like,
I think it's mostly terrifying.
yeah. Like maybe in a good way.
I think it's
like purifying.
I think it's terrifying in a productive way.
Yeah.
But I think it's emotionally a very nerve-wracking experience.
Is there art, science to the writing of the 6-page memo? Or just writing in general too?
It's really got to be a real memo. So it means, paragraphs have topic sentences, they can use verbs and nouns. That's the other problem with PowerPoint presentations. They're often just bullet points, and you can hide a lot of sloppy thinking behind bullet points. When you have to write in complete sentences with narrative structure, it's really hard to hide sloppy thinking. So it forces the author to be at their best. And so they're getting somebody who's really their best thinking. And then you don't have to spend a lot of time trying to tease that thinking out of the person. You've got it from the very beginning. So it really saves you time in the long run.
So that part is crisp and then the rest is messy. Crisp document.
Yeah, so you don't want to pretend that the discussion should be crisp.
Yeah.
There's, most meetings you're trying to solve a really hard problem. There's a different kind of meeting which we call weekly business reviews or business reviews. They may be weekly or monthly or daily, whatever they are. But these business review meetings, that's usually for incremental improvement, and you're looking at a series of metrics. Every time is the same metrics. Those meetings can be very efficient. They can start on time and end on time.
So we're about time, which is a good time to ask about the 10,000-year clock. That's what I'm known for, is the humor. Okay. Can you explain what the 10,000-year clock is?
10,000-year clock is a physical clock of monumental scale. It's about 500 feet tall. It's inside a mountain in West Texas in a chamber that's about 12 feet in diameter and 500 feet tall. 10,000-year clock is an idea conceived by a brilliant guy named Danny Hillis way back in the 80s. The idea is to build a clock that's suitable for long-term thinking. And you can kind of just very conceptually every 1,000 years. So it just sort of slows everything down. And it's a completely mechanical clock. It is designed to last 10,000 years with no human intervention. So the material choices and everything else. It's in a remote location both to protect it, but also so that visitors have to kind of make a pilgrimage. The idea is that over time, this will take hundreds of years, but over time it will take on the patina of age, and then it will become a symbol for long-term thinking that will actually get humans to extend their thinking horizons. And in my view, that's really important as we have become, as a species, as a civilization, more powerful. You know, we're really affecting the planet now. We're really affecting each other. We have weapons of mass destruction. We have all kinds of things where we can really hurt ourselves. And the problems we create can be so large. You know, the unintended consequences of some of our actions, like climate change, putting carbon in the atmosphere is a perfect example. That's an unintended consequence of the Industrial Revolution. Got a lot of benefits from it, but we've also got this side effect that is very detrimental. We need to start training ourselves to think longer term. Long-term thinking is a giant lever. You can literally solve problems if you think long-term that are impossible to solve if you think short-term. And we aren't really good at thinking long-term. As you know, it's not really, we're kind of, 5 years is a tough time frame for most institutions to think past. And we probably need to stretch that to 10 years, 15 years, and 20 years, and 25 years, and we'd do a better job for our children or our grandchildren if we could stretch those thinking horizons. And so the clock is, in a way, it's an art project. It's a symbol, and if it ever has any power to influence people to think longer term, that won't happen for hundreds of years. But we have to, we're going to build it now and let it accrue the patina of age.
Do you think humans will be here when the clock runs out here on Earth?
I think so. But the United States won't exist. Like whole civilizations rise from 10,000 years is so long. Like no nation state has ever survived for anywhere close to 10,000 years.
And the increasing rate of progress makes that even
less likely. So do I think humans will be here? Yes. What how will we have changed ourselves and what will we be and so on and so on? I don't know, but I think we'll be here.
On that grand scale, a human life feels tiny. Do you ponder your own mortality? Are you afraid of death?
No, I used to be afraid of death. I did. I remember as a young person being kind of very scared of mortality. Didn't want to think about it and so on. Always had a big. And as I've gotten older, I'm 59 now. As I've gotten older, somehow that fear has sort of gone away. I don't. I would like to stay alive for as long as possible, but I'd like to be. I'm really more focused on health span. I want to be healthy. I want that square wave. I want to, to be healthy, and then gone. I don't want the long decay. And I'm curious. I want to see how things turn out. I'd like to be here. I love my family and my close friends, and I'm curious about them, and I want to see. So I have a lot of reasons to stay around, but mortality doesn't have that effect on me that it did, maybe when I was in my 20s.
Well, Jeff, thank you for creating Amazon, one of the most incredible companies in history, and thank you for trying your best to make humans a multiplanetary species, expanding out into our solar system, maybe beyond, to meet the aliens out there. And thank you for talking today.
Well, Lex, thank you for doing your part to lengthen our attention spans. Appreciate that very much.
Thanks for listening to this conversation with Jeff Bezos. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Jeff Bezos himself. Be stubborn on vision, but flexible on the details. Thank you for listening, and hope to see you next time.
from either side because the probability of dying is incredibly high. So in order to overcome defense in depth trenches and minefields, you really need significant local superiority in numbers. Ideally combined arms, where you do a fast attack with aircraft, you take a concentrated number of tanks, and a lot of people. That's the only way you're going to punch through a line. And then you're going to punch through and then not have reinforcements just kick you right out again. I mean, I really recommend people read World War I warfare in detail. It's rough. And the sheer number of people that died there was mind-boggling.
It's also possible to imagine the end of it that doesn't look like almost exactly like the beginning in terms of what land belongs to who and so on. But on the other side, there's a lot of human suffering, death,
Yes.
and destruction of infrastructure.
Yes, the thing that the reason I proposed some sort of truce or peace a year ago was because I predicted pretty much exactly what would happen, which is a lot of people dying for basically almost no changes in land, and the loss of the flower of Ukrainian and Russian youth, and we should have some sympathy for the Russian boys as well as the Ukrainian boys. The Russian boys didn't ask to be on that front line; they have to be. So there's a lot of sons not come back to their parents, and I think most of them don't really have. They don't hate the other side. It's sort of like there's this saying about this saying comes from World War I. It's like young boys who don't know each other killing each other on behalf of old men that do know each other. The hell's the point of that?
So Volodymyr Zelensky said that he's not, or has said in the past, he's not interested in talking to Putin directly. Do you think he should sit down, man-to-man, leader-to-leader, and negotiate peace?
Look, I think I would just recommend do not send the flower of Ukrainian youth to die in trenches. Whether he talks to Putin or not, just don't do that. Whoever goes on the offensive will lose massive numbers of people. And history will not look kindly upon them.
You've spoken honestly about the possibility of war between U.S. and China in the long term, if no diplomatic solution is found. For example, on the question of Taiwan and one China policy.
Right.
How do we avoid the trajectory where these two superpowers clash?
Well, it's worth reading that book on the difficult to pronounce Thucydides trap, I believe it's called. I love war history. I like inside out and backwards. There's hardly a battle I haven't read about. And trying to figure out what really was the cause of victory in any particular case, as opposed to what one side or another claims the reason.
Both the victory and what sparked the war.
Yeah.
The whole thing.
Yeah. So that Athens and Sparta is a classic case. The thing about the Greeks, they really wrote down a lot of stuff. They loved writing. There are lots of interesting things that happen in many parts of the world, but people just write down. So we don't know what happened, or they didn't really write in detail. They just would say we had a battle and we won. Like, well, yeah, a bit more. The Greeks, they really wrote a lot. They were very articulate on it. They just love writing. So, and we have a bunch of that writing that's preserved. So we know what it's inevitable that there's going to be a clash between Athens and Sparta. Well, how do we avoid that? And they saw it coming, and they still could not avoid it. So, at some point, if one group, one civilization, country, or whatever, exceeds another, sort of like, the United States has been the biggest kid in the block since I think around 1890, from an economic standpoint. So, the United States has been the most powerful economic engine in the world longer than anyone's been alive. And the foundation of war is economics. So now we have a situation in the case of China where the economy is likely to be 2, perhaps 3 times larger than that of the U.S. So imagine you're the biggest kid on the block for as long as anyone can remember, and suddenly a kid comes along who's twice your size.
So we see it coming.
Yeah.
How is it possible to stop? Is there let me throw something out there, just intermixing of cultures, understanding. There does seem to be a giant cultural gap in understanding of each other. And you're an interesting case study because you are American, obviously. You've done a lot of incredible manufacturing here in the United States, but you also work with China.
I've spent a lot of time in China and met with the leadership many times.
Maybe a good question to ask is, what are some things about China that people don't understand, positive, just in the culture? What's some interesting things that you've learned about the Chinese?
Well, the sheer number of really smart, hardworking people in China is incredible.
Outward looking, like the way you are, like sitting with a good friend, looking up at the stars, like asking pothead like questions about the universe, wondering what it's all about, the curiosity you talk about. There's a sense, no matter how mundane the question I ask it, there's a sense of cosmic grandeur to the whole thing.
Well, we are actually working hard to have engineering, math, and physics answers that you can count on. So for the other sort of AIs out there, these so-called large language models, I've not found the engineering to be reliable, and the hallucination. It unfortunately hallucinates most when you least want it to hallucinate. So when you're asking important, difficult questions, that's when it tends to be confidently wrong. So we're really trying hard to say, okay, how do we be as grounded as possible so you can count on the results? Trace things back to physics first principles, mathematical logic. So underlying the humor is an aspiration to adhere to the truth of the universe.
That's really tricky.
It is tricky. So that's why, there's always going to be some amount of error, but do we want to aspire to be as truthful as possible about the answers with acknowledged error, so that there's always, you don't want to be confidently wrong. So you're not going to be right every time, but you want to minimize how often you're confidently wrong. And then, like I said, once you can count on the logic as being not violating physics, then you can start to build on that to create inventions, like invent new technologies. But if you cannot count on the foundational physics being correct, obviously the inventions are simply wishful thinking, imagination mind. Magic, basically.
Well, as you said, I think one of the big goals of XAI is to understand the universe.
Yes. That's also a cool 3-word mission.
If you look out far into the future, do you think on this level of physics, the very edge of what we understand about physics, do you think it will make discoveries, sort of the sexiest discovery of them as we know now, sort of unifying general relativity and quantum mechanics? So coming up with a theory of everything. Do you think we could push towards that direction, almost like theoretical physics discoveries?
If an AI cannot figure out new physics, it's clearly not equal to humans, let alone nor has surpassed humans, because humans have figured out new physics. They're just good. Physics is just understanding, deepening one's insight into how reality works. And then there's engineering, which is inventing things that have never existed. Now, the range of possibilities for engineering is far greater than physics, because we once figure out the rules of the universe. That's it. You've discovered things that already existed. And from that, you can then build technologies that are really almost limitless in the variety and it's like once you understand the rules of the game properly, and with current physics, we do, at least at a local level, understand how physics works very well. Where our ability to predict things is incredibly good. Quantum mechanics is the degree to which quantum mechanics can predict outcomes is incredible. That's my hardest class in college, by the way. my senior quantum mechanics class was harder than all my other classes put together.
To get an AI system, a large language model to reliably be as reliable as quantum mechanics and physics is very difficult.
Yeah, you have to test any conclusions against the ground truth of reality. Reality is the ultimate judge. Like physics is the law, everything else is a recommendation. I've seen plenty of people break the laws made by man, but not break the laws made by physics.
It's a good test. If this LLM understands and matches physics, then you can more reliably trust whatever it thinks about the current state of politics.
And it's also not the case currently that even its internal logic is not consistent. So it's especially with the approach of like just predicting token, predict token. It's like a vector sum. You're summing up a bunch of vectors, but you can get drift. So as a little bit of error adds up, and by the time you are many tokens down the path, it doesn't make any sense.
So it has to be somehow self-aware about the drift.
It has to be self-aware about the drift, and then look at the thing as